So let's begin. Uh, of course, for those who don't know me, my name is Latonya Wabugu or Wabugu Latonya in any order that will work. And I want us to look at something very interesting that we call uh, innovation methodologies. In here, we understand how problems become solutions in a structured and academic exploration. Structured and academic exploration. Uh, and you know, one of these, especially, this will be very useful if you are writing a technical, innovation-oriented paper, research paper. And we can note the differences and how you can become more skilled when you're writing papers that are technical, of technical orientation, or more experimental orientation. May it be you you are really doing like coming up with a prototype or a method and how to come up with that method. And this is how one of the key important thing when you are experimenting, you do something that we call iteration. Iteration is you experiment, you perform various experiments of the same, whereby each experiment changes some variable and you look at the outcome. If the outcome is not what you expect, does not solve the problem, then you change the variables and you have a different variable. And then you have another experiment. You iterate the experiment that you did before. You repeat it, only that this time you have changed some variables or you have changed some of the materials or something. Maybe the materials were not working the first trial. Second trial, you change something, and then that will be the same method, but you have changed something in the process, the same process. And then you look for the results, you test the results to see whether you have come close to solving your problem. And the one that usually works the most is the one that really approaches the solution or best satisfies the user satisfaction. Remember what we looked at yesterday? We looked at how innovation is really about user satisfaction and how the impact that it has on the users. And this is where now you look at the design or how you satisfy the customer. You solve the problem, and does the user is it user friendly? Because it can solve the problem, but maybe it is too technical. Maybe your problem can only be used by some expert. So, but just imagine you have a mobile phone with you, and this mobile phone uh, is a computer. Okay, years ago, this to use a computer, you had to be an expert, especially those big computers that were very old. They used to fill the whole building. The only person who could operate that computer was an engineer. So that at that point, that was just an invention. For it to become an innovation, you have to really do some customer or user satisfaction. Yes, it can solve the problem of calculating as a calculator or sending messages and everything. But can the user be able to use that computer? Now, this day, a very complex gadget here, which is a computer, which is very powerful, can take photos, can do everything. This is very complex, but yet anybody, even a child, can use this object. That usefulness from a computer that used to be used by very technical people or engineers, and now this gadget can be used by a child, that has impact on society, and that is when your invention becomes an innovation. Um, so uh, we look at an innovation that didn't happen. Okay, so these are ideas in your mind today. You have a solution for something, but this did not come to happen. It did not go through the invention process, and then it did not become an innovation because it does not have any impact on the users. And there are very many reasons why uh, your or your idea cannot become an innovation. First, you have to realize it through invention, and then you have to actualize it to um, to make it an impact, to adopt it to the users, to the people that you want to address their problems. So one thing, two things can make your invention not reach become an innovation is that one, maybe it is solves the wrong problem. You don't have an understanding of the problem. You have to go deeper. You listen to the people uh, who have that problem. You know, because if you don't understand what they are suffering from, you might create a solution for an idea for your idea of the problem that you think they are suffering from, but just because you have not gone deeper to search what your users are suffering from, what is their need. So uh, to that process, because we are saying an innovation that did not happen, it can become an invention, but you solved the wrong solution because you do not understand the problem clearly. So uh, we need to have a process. Innovation is a process, so that we don't keep on, trivial solutions. It's not something that just occurs like that. It's a process that can be repeated by other people. Okay, it can be standardized. So every innovation that exists today was once an idea. It was sitting in someone's head, the comobrogoid, the cogosity. Uh, for every innovation we see, thousands never happened. And there are very many reasons why those innovations did not happen. Because one, lack of confidence, uh, lack of confidence that you have an idea that can solve a problem, but you don't believe that your problem, as we said yesterday when we were talking about innovation, we said that an innovation is not let me read it here, just to read what we said. What is an innovation? Yeah? Or we said the core truth of, of, of innovation is that innovation is not limited to experts. Okay, um, innovation skills can be learned since they can be summarized into a process, a standard process, so everybody can learn to, to innovate. Uh, we also said that innovation must be practical and context driven. Context driven means that you understand the problem and the people. Okay. Well, so you may, like, for example, you say maybe the transport system in Kenya does not work. Then you go to London and you look at how they do their transportation. And then you go adopt that system to Kenya. But you have not understood Kenyan ways of thinking, the people, the culture, everything. So it has to be, you have to have listen to the people, you have to understand the situation, you have to understand the resources available, context driven innovation. And we also see that innovation must begin with understanding the problems. So those things, if you don't do those things, then your innovation will not happen. Your idea will not happen. First of all, your confidence, your belief that you can actually do it. Number two, you have to follow a certain processes so that you can make sure that first you understand the problem. Second, you you try to iterate. It's repeatable. The process must be repeatable. So whatever you are doing must be repeatable so that you can iterate. If you did some mathematics in college, remember when we say that iteration is finding a solution, a problem-solving method that best aligns to the solution. So you repeat that until you get something that is the most ideal. You don't get the 100% solution. You always get to an approximation of the best. Okay. So many problems persist, not because they are unsolvable, but because they have become normal. So many problems persist, not because they are unsolvable, but because they have become normal. In other words, what we usually say is that those problems can become invisible. We just accept that. One of human element is that uh, sometimes when maybe let's say you are living near a sewage, at a certain point they might just adjust, and that foul smell of the sewage it becomes known. Okay, so it becomes invisible. So you are traveling by road, you find somebody who lives near a sewage. There's a sewage somewhere. You find those people are living normally. They are not feeling as if there's a false smell. The brain adjusts very quickly. Sometimes you can even adjust to pain. You go through pain, your mind can adjust to ignore that pain. Um, if you are working, your work, where you go to work, the work is very difficult because of certain things. You can accept the difficulties and live with it, which is it's also actually a powerful thing that human beings have if the problems are solvable. So when a problem persists, it persists because it can become normal. So if you look at this picture, you can see the innovation that did not happen. First, you look at on one side there is a tractor and a city behind, and then you can see the other one, there's a barn and somebody farming using a horse. What you need to know about that is the number of years that human beings used horses. Thousands of years. Do you know how many years we have used tractors? Not more than 100 years. But horses were being used in the time of Jesus and before that. To all those years, what is are you saying that technology is an evolution that must happen with time? No. What did these people? There are people who had ideas, but they did not. Uh, they did not. They did not prevail. Those ideas did not happen. They happened later. So you find that there are innovations that could have happened earlier, like the discovery of electricity, could have happened 500 years ago. What if electricity was discovered? Electricity is not older than maybe 150 years. But what if it did happen years ago? What if it was discovered in the time of Jesus? Where would we be? So, uh, first question there is why didn't this innovation happen sooner? Why did they fail to notice? And what assumptions blocked the idea? Okay. Why does this matter for innovation? Problems we accept become invisible. Invisible problems never get solved. So problems we accept become invisible. Invisible problems never get solved. That is something we mentioned before, that if a problem persists, it can be accepted as normal. So that when it is accepted as normal, it becomes an invisible problem that, and when it is invisible, it can never get solved. So we have to question the norm. We have to think out of the box. We have to question: do we really have to go through this pain? Okay. Innovation does not start with the solutions. Okay. That is something very important, that you can just go and create something and then you say this can solve very problem. So innovation does not start with solution. It starts with noticing what we have learned to ignore. What we have learned to ignore. Okay. So there is something that people normally do that is tiresome, that they have accepted, and you notice that maybe we can do better. So innovation starts with noticing what we have learned to ignore. And you have to know that innovation is a process. So innovation follows structured stages. These processes, they reduce reliance on individual brilliance. Sio kusema hapa ati wewe ni genius. We don't rely on individual brilliance. Remember, humanity is a social animal. Human is a social animal. We are not like leopards. Okay. And to go a bit veer off the topic is that if you enclose a leopard, if you feed it somewhere, it cannot see anything else, just eat. It's like a leopard will live very well. But if you enclose a human being somewhere there is light and only give that person food, that person can become crazy because you are not made to be a single entity. You are a part of a community. And that's why, and that is something that we know. Okay. So we want also, from innovation perspective, reduce reliance on individual brilliance. And that's why we say yesterday, walk on a beaten path where people have already walked, so that you don't reinvent the wheel. Next, repeatable processes enable consistent innovation. So we have these processes that can be used by anybody and they can be followed. Okay, they are standard because they will reduce misuse of resources. Because you are doing something, you are just working on a big ambiguous method. So you're not following instructions. It's more like cooking. What we do when we are cooking at home, we don't use recipes. So that one, there is inconsistency. What you cooked, the kaugari you cooked yesterday, does not taste. Maybe today, do you find sometimes that when you cook it, sometimes the food tastes good, sometimes it does not taste good. You know that. That is because you don't have a recipe. Why do you think that there are millions of recipes, and you can go to the people in the department, food and beverages, they have recipes. You follow this recipe, you attain a certain texture of food, certain smell, a certain taste. Okay, and through those recipes, because they have been researched on, you reduce wastage. Okay, you don't buy unnecessary stuff. You reduce ambiguity. So repeatable processes, they enable consistent innovation. Okay, so that idea of achieving the same taste of food, which is good, sio kuangukia, that is what the same way in innovation, so that we can enable consistent innovation. So we also have an approach here where we want to see how do we get from the problem to innovation. The first thing you have to do, number one, is understand the problem deeply. Okay? Usikuje uangalie watu kwa kagroup uone wamenyamaza, wewe useme ujijazie wamenyamaza kwa nini. You must go and inquire. And I give an example yesterday of a mechanic. A mechanic ukimpelekea gari, kitu ya kwanza anafanya ni kukuuliza ni nini gari inafanya, ndio ajue when you accelerate sijui ni nini inafanya. That way a mechanic arrives, a good mechanic will always ask the driver where he thinks the problem is, or the challenges he is meeting. Maybe the vehicle is not accelerating when you are overtaking such things. So when you ask, you can, because you have the knowledge as a mechanic, then you can be able to pinpoint or diagnose or troubleshoot where the problem is. So in any case, you can apply that to any kind of problem solving. So when you want to move from problem to innovation, number one is you have to understand the problem deeply. Number two, you have to generate solution ideas, and these solution ideas can be various of them to see which one works the best. Okay, and then you have to test these ideas. You have to test and refine the solutions. So by testing and refining, that is what we call iteration. You test, you find that maybe you achieved this was problem. Maybe if you are doing in building, the stress was iliangukia mahali fulani, you have to go beyond that. Then you try to maybe change the materials or increase the surface area or something. You change variables. Or if you are doing a process maybe in applied science, maybe you used these ingredients, or used a certain you change the temperature. This time you observe the solution. Maybe like, you remember the guy who was selling us the jelly for applying bread. Yeah? So when you come up with those jellies, I'm calling them jellies because I've forgotten the name of the jam. But now maybe it's becoming acidic. Maybe you change a certain variable. You take the same jam, you go and give it to the people. You tell them to taste, which is kind of understanding the problem. And then you change a little bit. You iterate. You improve on the previous test. You improve on the previous attempt. Then you have to deliver. Finally, after you have shared the best solution, that solution will not become an innovation unless it delivers through value through adoption. So you have to adopt it, you have to package your stuff and give it to the users, and the users accept it, they see it is good, and they adopt it, and they can now buy from you. That's when it becomes an innovation, when it is useful to them and it has impact. What is a methodology? Because we are talking about innovation methodology. So a methodology is a structured way of thinking and acting. Okay, because just I want to remember, your mind is like the universe. It can think in any way. You just wake up and you can think randomly about something and you can go in any direction. But in order to achieve something, you have to have a structured way of thinking and acting, especially in research and innovation. Methodology guides how problems are understood, approached, and solved. As we said, you have to understand the problem first. Then how do you approach that problem so that you can solve it? So it guides how the problem is understood, approached, and solved. Methodologies, they reduce uncertainty. Okay? They reduce uncertainty. And they replace guesswork with logic, which is very critical. You replace guesswork with logic. Methodologies can be very good for problem solving. Why methodologies matter in innovation? Why do methodologies matter in innovation? So innovation involves uncertainty and incomplete information. And the methodologies provide discipline to creativity. So they help avoid solving the wrong problem well. So if you, for example, you get to a village, and this village is in Treto constituency, and you hear that those people in that village, they don't have water. Then you assume that these people, they don't have machines for digging wells. Okay, so you go and buy a machine for digging wells up to 100 meters, and the pumps and everything. Only to go to Teto constituency and you find that there are rivers and there are you can just go to the forest and create a catchment area and you have water and it will go down to the village through gravity. You don't even need a pump. And you have solved the problem very well, but you have used a lot of machines. You need to use electricity, the pumps, and everything. A lot of expenses unnecessary. So you are solving the wrong problem very well. So that is because you have not understood the problem very well. You have to understand the problem, and you have to have discipline in your creativity. Methodology versus method versus tool. Methodology is the overall framework for thinking. The overall framework for thinking. Okay. The method is a specific approach within a methodology. A specific approach, because there are various methodologies. That those one of those is a specific approach within a methodology. And the tool is a technique used at a particular stage of methodology. We'll come to look at them later as we continue. So there are various types of innovation methodologies. As you can see, there are four of them. We have one, human-centered methodologies. And then you have knowledge-driven methodologies. Then you have constraint-based methodologies. And you have value and market-driven methodologies. Value and market-driven methodologies. So you can look at them. Human-centered methodologies, knowledge-driven methodologies, constraint-based methodologies. When you look at constraint, it means you are looking at cost, availability of materials, okay, and things like that, availability of human resources, all that. Then we have, we look at the overview of innovation methodologies. These are the four types of innovation methodologies. So we have the design thinking, where we look at human needs. The design thinking, where we think of human needs. Then we have the scientific method, which is the knowledge-based, knowledge discovery. It's knowledge-based, and then you discover a solution which can become an innovation. Then we have engineering design, and this for engineers, problem solvers, and you look at feasibility and constraints. What are the constraints? Constraint-based engineering design. We look at them deeper. Then we have lean innovation, where we look at value and viability. And lean innovation is where you try to reach the problem the fastest way possible, and also to solve that problem and give it value. So let's look at the design thinking strategy, which is based on is human based. Which are the core stages of design thinking? As we said, we go back here. We have design thinking, we have scientific method, we have engineering design, and we have lean innovation. So we look at design thinking, which has uh, 5 core stages. Number one, empathizing. You know what is to empathize? To empathize is to wear someone's shoes. Okay, to be in someone's shoes. To look at their thinking, their feeling, their experience exactly the way it is. Okay, you put yourself into their position. You like if you are a doctor. If you are a doctor and you cannot empathize, you will be a very bad doctor. Because when a person tells you, I have a headache, and you tell them, no, I think you have a stomach ache. Okay? You are not empathizing with that sick person. So you have to empathize. That's the first stage in this methodology, design thinking. You empathize. And then number two, you define. Look at these stages, all of them. You define, you ideate, create a prototype, and then you test. Remember, this process is repeatable. That is what to repeat the process by changing. Maybe you do not understand the person correctly. You go back to the person, you tell them, okay, how do you feel the taste of this jam? Okay, that person tells you, I feel it is bitter. So you empathize with that person because now if that person says it's bitter, okay, then it must be bitter. Some of these people might like bitter things. Okay? So someone like me, the guy who was from the trainer, the, who was giving us jam, it is tasted very sour, and I like sour things. But someone else might like the sweetness and not the sourness. Also, the like the yogurt, yogurt from agriculture department is a bit sour, and I like that one. I like that one. So there are people like me who like this more like maziwa mara, and the other one is more like refined, like the one you buy in the shop. It depends with you have to empathize with uh, with your users, and your users can be different. And that when we say contextualize, the context is very important. It might be something you are selling is not acceptable because of culture. Like now you go and say and create a very nice product of pork in Saudi Arabia. You are not empathizing with Saudi Arabians. Or come up with a very nice process of skewing and whatever you do to meat um, snakes, and you bring them to Mount Kenya region. You're not empathizing with the Mount Kenya people. So the first step is to empathize, to understand the people, uh, the problem. You have to empathize. Then you define what you have, the problem. Then you create ideas to solve that problem. You create a prototype and you test that prototype. You can go back to the so that you can re-empathize. And that is if that process is repeatable or iteratable, then that is a very uh, good methodology for innovation. So what is to empathize? You understand the users in their real context. You understand the users in their real context. Okay. You observe behavior, workarounds, and frustrations. Okay. You reveal hidden and unspoken needs. You can reveal hidden and unspoken needs, something that the user is not even able to explain. Maybe it's a software, and whatever their frustration is, they cannot even tell where the problem is. So you can even look even deeper. What does this person need? They may express um, frustrations, but they don't actually understand what they actually need. So you are even going much deeper sometimes. Then the next stage in design thinking is to define. So to define is you synthesize your observation. You synthesize, you separate the symptoms from root causes. Okay, like a doctor. The doctor now listen to the person saying, "I have a headache, I am diarrheaing, I don't know what." Huh? Like the person who went to the hospital to see a doctor, and he told the doctor, "Doctor, when I touch my face, I feel pain. When I touch my chest, I feel pain. When I touch my knees, I feel pain. When I touch my nose, I feel pain." And the doctor really empathized and told the person, "Your figure is broken." Okay? Because he was feeling pain everywhere. So you understand, you even understand the need of that person that he is not aware of. So you separate the symptoms from the root cause. If the person is coughing, you don't say alcohol akona cold. You have to go deeper. So you understand the root cause of the problem, not treating the symptoms. So that is now defining your observation. Then you frame a clear human-centered problem statement. You frame a clear human-centered problem statement. And then, of course, you have the problem statement. And those problems that you observe during the methodology process, especially in design thinking, those are problems that now you input if you are writing a report or a proposal or innovation centered or innovation paper. These are the ones that you put in the problem statement. Those problems. A clear human-centered problem statement. The next stage is you ideate. To ideate is to expand the solution space. So you come up with several ideas to solve that problem. So you expand the solution space by generating multiple solution pathways. Then you delay judgment to encourage originality. That's when you delay judgment, that's when we say you are objective, not subjective. Okay? You delay judgment to create or to encourage originality. That's how. Then the next one, after you have ideated, to ideate is to create, to expand your solution space so that you have very many solutions and then you come up with the best one of them. You prototype, you turn your ideas into tangible forms. You turn those ideas into tangible forms so that you iterate, okay? You enable iteration and early learning. So when you start to iterate, you come up with a prototype, you test it, you change the variables so that you improve your trial or the second one is has improved for the test. You are iterating so that you come closer to the solution, to the best solution possible. Then you expose during the prototype. That's when you expose design flows quickly. You expose those design flows. Hapa nilitumia copper. Nilitumia aluminium instead of copper. Aluminium is not as good conductor as copper. Maybe gold is better, but gold is expensive. So you are looking at all those flows. maybe this joint I used here is not the best. Maybe this, when I was trying to extract chemicals, when I was making the pesticide, when I was extracting, I used a certain method instead of slow distillation or something. So when I used this method, the concentration was like this, or the strength was like this, the stress field at a certain point, it was not able to do this. So you expose the design flows quickly. And when you design those flows, that is when you iterate. You repeat the process with changes. Okay. Yeah. So you come up with prototype two. You had prototype one, prototype two. If you look at, maybe you look at robots, you have seen these humanoid robots. They usually come up with different iterations. You can have like which robot do you know? Boston robots or Asimo. You have Asimo 1, Asimo 2, Asimo 3. And when you look at these robots as you go from maybe 1.0 to 2.0 to 3.0 to 4.0, each of them keeps on improving. Remember, iteration can occur. Remember, you can achieve a prototype and then actually uh, um, you actually take it to the market and becomes an innovation. But during that, when it's being used by the users, you have an opportunity to now empathize with them as they tell you these are the problems they are facing. And that's why you hear that maybe a certain car type is being returned to recalled to maybe brake failure or something. They return it to the seller or to the industry, to the manufacturer, and they improve. Or maybe your phone, especially iteration occurs on when you're using your mobile phone. These days they have software that looks at whatever you are doing, the problems that you are facing, they look at very many people. Several people are saying that mobile phone is hanging when you open this application, when you do this. So that when you come to the next phone, the next version, like let's say it's a Spark Pro 10, go to Spark Pro 11, you see an improvement of the previous one. That is what we call iteration. So iteration can occur as you go from one innovation to the next one, or the one prototype, especially when you are testing, to the other one, when you make changes and you improve to best get to the best solution for a problem. So this is where you get to see those design flows and you improve on them. Uh, yes. Then the next stage after iteration is you test. You test where you collect real world feedback. Okay, and when as we said, you can get from the users. They tell you, oh, this is not working. This is doing this. I don't know. Either it's super happy. Either it's super happy. Then you collect. It's very important to collect feedback from your users, even like our process here, because we offer training. It's good to have feedback. When you collect feedback, you improve on your whatever you are following, maybe the training process, and you must be flexible for change. You must be flexible for change where you improve on what you are doing. You don't become rigid and say whatever we do, we are trained with the pedagogy. I am a professor of I don't know what, and then your trainee tells you this method you are using, I'm not learning. Then you are very rigid to change. You must be ready to change. So when you test, you get the feedback, and then you go back and change. You refine and redirect the solutions. You refine and redirect the solution. Maybe uh, you change the recipe, you change some ingredient, maybe you change the width of a certain member of your structure. Uh, Maybe you change a module within your software. You change a module within your software, okay? Um, or a class or something. You use a different solution or some variable, change the variable. So you are redirecting. You can even change the solution altogether if it's not working. So it's not working for that particular problem that you're working on. So you redefine and redirect the solution, and you learn through iteration as you keep on changing from one to the other. Okay. The, then we go to the next stage, and maybe before you go to that one, let's go back here and look at just a refresh of the design thinking. So you have these three, four, five stages: empathize, define the problem, and then you expand, ideate. You expand the solution space, have various solutions. Then you create a prototype, you test to iterate. Okay. Then the next or the other um, innovation methodology is the one that we call scientific method. And scientific method has 6 core stages. Number 1, observation. Number 2, question. Number 3, hypothesis. You form a hypothesis. Number 4, you experiment. You experiment, experimentation. Number 5, analysis. Do an analysis. And number 6, you form a conclusion. Okay. This one you are a bit familiar with it. So let's look at these stages, each of them, what it means. In observation, you identify anomalies or unexplained phenomena. Okay, maybe there is uh, these days. What can we put here? Let's say environmentally, you can look at anomalies. You say um, the weather uh, or the climatic seasons uh, these days um, they are not normal and they are unpredictable. Why are they changing the weather patterns? So you identify that anomaly and or unexplained phenomenon. You notice where existing explanation fail. So these are the usual explanations of people. They say maybe the planet has tilted or whatever, but then you find that all these explanations, they are failing to explain the phenomenon. You go to the next stage. After you have done the observation, you identify the anomaly or the problem. You go to the next stage where you question. You translate curiosity into precise inquiry. Okay, you have been able to observe your problem, your phenomena, which is abnormal. You now ask, you do what you call precise inquiry. So you define the boundaries of investigation. Then you form a hypothesis. This is where you propose a logical and testable explanation. Propose a logical and testable explanation, but at the same time ensure falsifiability. You ensure falsifiability. So that's what it means to ensure falsifiability. Falsifiability come from here. So my tongue is a bit heavy. So falsifiability is where now it's actually uh, your explanation is testable. And when it is testable, it means it can either be right or wrong. Okay? So just you don't just say, today I have a hypothesis. Today it is Sunday. You know, you cannot falsify the fact that today is sunny and say it could be sunny, it could be not. That is not testable. So that cannot form a hypothesis. I hope now you can apply that to any other phenomena. The other stage after hypothesis is experimentation. So you design controlled test and then you generate reliable evidence. Generate reliable evidence. And this one is especially useful when, for example, whatever, especially during the formation of a prototype. So you design a controlled test and you generate reliable evidence. So those tests, you have those variables and values that you get. Those one, they form the reliable evidence. And reliable evidence means that now you can generate um, a conclusion. You can generate a conclusion. So you look at that data, which is reliable, and that data, you interpret it during the next stage, which we call analysis, where you interpret the collected data and you identify meaningful patterns. You interpret the collected data, you identify the meaningful patterns. Maybe, for example, I have a battery of 80 volts on my electric bike, and when I drive it, I charge it for 2 hours, or when I add a certain number of batteries or cells, so that I have a certain current or so forth, and I charge it for 2 hours or this amount of time, and then I drive it at a certain speed, I will have a distance, I will travel up to a distance or range of maybe 100 kilometers. When I change, I get to 60 kilometers. When I change these variables, I can get up to 120 kilometers after one charge. So once you collect that, you analyze, and you identify meaningful patterns. Maybe when I use this number of cells, means that uh, this motorbike or electric bike will travel a certain distance. So you identify meaningful patterns through looking at the relationship between the variables. And then from there, once you have identified the patterns, then you make a conclusion whereby you accept, reject, or you revise the hypothesis that you had formed. Okay? And this is where you formalize new knowledge or invention. Okay? You formalize new knowledge or invention. So as I said, it's good. The scientific method is good, especially when you are forming a prototype. That's when you are creating an invention. But you have to add another final process at the end, is that this invention must uh, must be impactful. Your invention must be impactful to people so that it becomes an innovation. Okay. So sometimes these methodologies you can combine them depending on what you are trying to achieve. So we look back, we go back to this list here, the core stages of the scientific methods, that is observation, the question. When you look at the question, then you have the hypothesis, experimentation, analysis, and conclusion. Okay. Number three, innovation methodology is what we call the engineering design, which also has 6 core stages. And that one is number one is problem definition. So in all of them, you are kind of trying to understand, to have a problem or to identify a phenomenon, an explainable phenomenon. They are important. They are all important. Like for example, what if, like the one we had before, which we called it the scientific method. A phenomenon could be a certain village. In a certain village, there is a preference. There is a occurring, frequent occurring of cancer cases. Okay, then you can form a hypothesis, maybe contamination of water, and then you have to test maybe the water. When you test, you look at the water pipes, you look at where the water is going through, the water tanks, and then somewhere you find maybe a pipe is they are using asbestos. So most of these we are starting with some a problem definition or identify a phenomenon. But in engineering design, you also start with a problem definition. Number two, you look at requirements and constraints. Requirements and constraints. And that's why engineers are very good at problem solving. When you, because you have to look at, you have to be realistic. Um, can we need electricity in Kenya? Uh, is it feasible? Could we be able to use nuclear energy? When you look at the cultural, the whatever, the cost, and all those things. So you will have to look at requirements and constraints. Number three, you have to you have to look at concept generation. Number four, design and modeling, prototyping, testing, and refinement. Again, iteration is also occurring here. You test, you refine, you test, you refine. Okay, so let's start with the first one, problem definition. You can define functional goals. You want to build a bridge which can go over something that has never been done before. You can go 120 kilometers over hilly places so it is not touching the whole ground. Okay, so you define what do you want to achieve. Define the functional goals and you specify performance criteria. This bridge that we build should be able to carry 1,000 cars up to maybe 1 million tons without failing. So you are specifying the performance criteria. Okay. So whatever you have, maybe okay, this jam, science, applied science, this jam that I want to create, I want it to be accepted by people, can tasting nice, it has this consistency, it has a nice texture, it is sweet, okay, and the performance is that that consistency. That okay, maybe what we could say is that we want a very good jam. Then about the performance criteria is that consistency, texture, taste. Okay, those are the performance criteria. So for various types of innovation, you have to define the functional goals of your of that so that you can. It's kind of a problem definition because you want to go up to a certain point to go up to a certain point to solve this or to let's say to create something that does something that becomes part of problem definition for an engineer. Maybe you want to build a building, okay, which is 1.2 kilometers high, the highest in the world today, and is being built in Kenya by people from Nyandarua National Polytechnic Building Department. Okay, so that becomes the functional goal. A high-rise building, and this building is not can undergo or withstand high widths, high speed widths, and oscillations. Okay, and these oscillations they don't resonate. Okay, and create a big problem that the house does not collapse. Okay, so now you look at you are looking at the performance criteria. It is not resonating the width, the direction of the wind. Okay, so you are defining problem definition, and now you have to solve that problem. High-rise building that is not affected by wind, I don't know what, evil. Then you look at the requirements and constraints. First, you look at you identify the cost, the materials, the safety, regulatory limits. In Kenya, the government policy says you cannot build more than 1 kilometer. So you have to look at these regulatory limits. Also, even the environment, maybe in Nakuru, you cannot build high-rise buildings. So you have to look at the constraints. Then you define realistic boundaries. Kenya cannot afford to build a 1 billion house where people are sleeping hungry or whatever. Okay, you define realistic boundaries. The materials you use, some of them have to be transported from, uh, depending on the kind of uh, whatever you are working on. Then we have the next stage, which is the concept generation. And in concept generation, once you have looked, you have defined the problem, you have looked at requirements and constraints. The third stage is you create concept. And this you do by exploring alternative technical solutions. And when you look at these solutions, when you use a particular solutions, maybe when you are building this high-rise building, you use concrete and steel. The trade-off of using concrete and steel is you have a lot of weight. Another solution is you can use steel, a bit of concrete, but also you have a lot of glass for walls. Okay? So uh, glass can break, but the building is light. So you have to look at, you evaluate the trade-off. Can you live with the trade-off? Okay. So this is where you're exploring different solutions. And when you arrive at a certain solution, you have generated a concept. Then the fourth stage is where you come up with a design and you model. So you simulate performance. This one, in any case, even if you look at these people who do building architecture, they build models. So you can go into a room that they have built models, and these models they simulate performance. So you can see when you have, if you watch any of those videos when they are trying to design high-rise buildings, is they build a model and then they simulate with air, moving air to simulate wind condition, or if a house is in water or earthquake areas, they simulate the earthquake, they vibrate the table as they build the house. If it is a car, you simulate the car. You build a car body, put it into a wind channel, and the wind blows over the car, and you observe whether the car is, you know, pressing on the ground more or would likely fly. If it's a plane, you have the wings design. You also put them through a wind channel. You observe the way the wind is blowing. You can observe turbulence, things like that. So this is where you come up with a model. And maybe it is textile. You design a certain nice cloth for cold weather, and maybe when that person wears, it has wool. Something is maybe the way you have designed the cloth can get you let you put these clothes into maybe a cold place and you test whether cold, then if it comes maybe you are designing a shoe for running like the one for who was Keboy who runs marathon was using the Adidas shoes. So those shoes are usually you simulate before you can simulate even using software. You can simulate electrical circuit. You can simulate chemical process if you are mixing chemicals. And then this is where you optimize your design, which is the best before now you build. So when you are simulating for different uh, iterations or different types of houses, different types of solution, different process of cooking, the different recipe of the same recipe that you have iterated. You simulate which one is likely to perform very well, and then you find the best is when you are calling it optimizing. You of course this is a form of iteration when you are designing and modeling. So create a model, you pass it through a wind channel, you see that it's not functioning, there is a lot of turbulence. You change the model a little bit, and then you see you are reducing the turbulence. It is becoming better and better at solving the problem. Maybe it's a type of wheelbarrow, it can carry more weight without the person getting tired, or something else. The, because you are forming the models and testing them, the final design is optimized before building the house, the wheelbarrow, the recipe, the process, everything. That is designing and modeling. Then you prototype. So you build working models, and this comes maybe you are making a mat making machine. You make that prototype and you validate the theory in practice. Sasa ile kanyumba ama ile prototype kale kagari ulikuwa unapiga, unajua ilikuwa ni a shape in the wind, okay, na ilikuwa inapigwa na upepo. You design the shape, it's much better, no turbulence, it has traction as the wind passes over the car. It has the reverse effect of a plane. Instead of flying, it is pressing on the ground more, therefore more traction, things like that. So you you build now a working car or a wheelbarrow or whatever you are making, you make it and you validate that theory in practice. So you come up with a jam or whatever you are doing. Now you have the prototype. You test it. For a person who is making a jam, the only way to test jam is of course to taste it yourself. And you put it in a container, you have a prototype. You have a package. Take it to somebody. Angalia hiyo package akwambie it's nicely packed. Test hiyo jambo akwambie wow. Sasa hiyo ni prototype. So you are validating that theory in practice. It's a working model, and that is what we call prototyping. Another stage is to test and refine. Once you have that prototype, you correct maybe wakati ulikuwa unatumia ile mat machine, wakati ulikuwa unashona motor ilikuwa ina heat, you go and they add a bigger motor. Okay, if you are making a drone, that drone um, that drone was being swept away by wind, so could not fly in a certain direction. So we changed the motors and propellers. Okay, so you are testing and refining. You are correcting the weaknesses. You are improving efficiency. For example, in a drone, you reduce the weight. It can fly for a longer period of time. It therefore can be reliable for scanning a whole farm. Okay, so this is where you do the testing and then you refine. And this here is actually where we say that this you are testing the prototype. This is the two of them: prototype testing, new prototype after refinement, testing again until you get to which works to near perfection. Best, which arrives near to the solution, the best. So you have efficiency and is more reliable. That those two are kind of iteration. Okay, and the first prototype, second prototype, third prototype, like that. Then that is the final stage in engineering uh, methodology. Now, engineering design methodology, we repeat again, has problem definition, requirements and constraints, concept generation, design and modeling, prototyping, testing, and refinement. Then we go to the next and the final type of innovation methodology, which has 5 stages. Where number one, you identify the value. You build minimal solution. And you can see that lean mixture. Lean mixture in car is when you are using least amount of fuel in a car. Let's say you have a lean mixture in car. Just try to give an example of what we mean. So you have a weak and lean mixture. So a weak, a rich and lean mixture. Rich, lean mixture. Lean mixture has a lot of fuel and less oxygen. Lean mixture has less fuel but more oxygen. So what you are trying is like you are being very economical, and you are trying to get which which method arrives at the solution earliest with the minimal resources. So here you identify the value. How how much does it take to solve this problem using this solution, this solution? The first thing is to identify the value. What does it take to build a dam? Then you build a minimal solution. Build a minimal solution. You do measurement. You learn. Once you learn, this happens when you do this. This happens when you do this. You iterate. You iterate. So you go back and change until until you get the one that arrives at the solution. What you are trying here is to be very economical. Me, I want to solve this problem. The fastest can be economical with the time. Or you can be economical with cost, or you can be economical with the resources. So you iterate or also scale to scale. So this methodology here is you are trying to achieve this. Maybe in times you can scale in time. Also use the least amount of time. Maybe what you want to solve requires a lot of speed. Uh, because of time constraint, you have to move very fast. So that is a lean innovation. Which problem solves in terms of time? In terms of cost, you want to use the least cost possible. Okay, maybe in a place where economic hardships or things like that. So because you are this problem, the methodology are very crucial depending on what. And remember, you can use a combination of these methodologies in solving, just coming up with innovation. So once you identify the value, you build a minimal solution, you measure, you learn, then you iterate. Let's look at these five. Number one, you identify value. So identify value is to define a value from the user's perspective. You define value from the user's perspective. And that happened when we moved computers from big computers that were located in one place that were the size of building, and they built personal computers that can be used in the house. This personal computer, first of all, is portable. Second, it can be used easily by the user. Number three, it was cost effective. You can easily buy. So you're defining value from the user's perspective. Is it expensive? Is it usable? Is it portable? You're defining that value from the user's perspective. Then you formulate a value hypothesis. Formulate a value hypothesis. Number two, build a minimal solution. Develop only essential features. Develop only essential features, those that are necessary. And then you enable fast learning. You enable faster learning. Third stage, you measure, you correct real world data. So you correct real world data. You replace opinions with evidence. You replace opinions with evidence. That's how. You correct real world data. You replace opinions with evidence. That's how. So sio maneno ya kunena tu, unakuja na evidence once you measure. And remember, you had formed minimal solution, then you measure that, you learn, you interpret the results, adjust strategy based on insights. This is very similar to what we have already done. Then you iterate. To iterate is improve what works and stop what does not. And this method of lean, for example, because let's say you want to design an economic drone using AI system, or you want to create a program, a software that can make a humanoid robot to work naturally. So what they do is they simulate an environment where every constraint of that humanoid robot is input. The design, the shape, everything is input in that simulation. And then you form that similar robot in a simulated environment virtually. And then once you input it there, you mix like 1,000 of them, and you give them a mission to walk for 100 meters, meeting several obstacles. Then you observe how these different simulated robots do. You take the best 100, and the best 100, you take each and you multiply by 10. So you also have another 1,000 of them. Only those those 100 represent they represent the 100 best in the previous 1,000. So you have taken the best 100 and deleted the other 900. Then you take these best 100, you multiply each by 10, and you simulate them. Then you take 100, that is the second generation. You take 100, you delete the 900, and the 100, you multiply each by 10, and you go to the next stage. Each time you take the best. So you can evolve a working simulated robot by a million times. So what they usually end up is they end up with a software that behaves as if it is not normal, okay, as if it is natural. So you have a robot that's walking like a human being. You have a spider, a robot spider that moves, feels almost scary like a spider. Or you have a drone. When you see this drone, they can fly with water. You can put a cup of water or a glass of water on a drone and it flies at high speed without pouring any drink, any water. That means it was made by this method of lean. Okay, you improve only what works. You don't improve what does not work. Okay, if this does not work, you do it away with it. If this is expensive, do it away with it. You only work on what is working. Then you unify insight. So methodology, sorry, this is the last one, like iterate and scale. So look back at lean innovation. It has three stages. You identify value, the cost and everything, the time that you want. You identify what's the value that you want to work on. Then you build minimal solution. Then you measure, you learn, you iterate, or scale. So what is common in all these methodologies? Methodologies, structure, thinking, order, and certainty. Structure, thinking, others, especially when you try to find a problem to a certain, a solution to a certain problem. These solutions can be many. How do you structure? Because you don't have to be ambiguous. Okay, huh? You know, so you have to structure the methodology. They structure your thinking. Methodologies, they also discipline your creativity so that you are not flying all over the world when you are trying to come up with a solution or come up with a solution to the wrong problem. Okay. The other thing is innovation succeeds through informed iteration. So to be informed is when you are testing and coming up with this is the problem. Let's use another material. Let's use another process. Let's use this. You are iterating and coming up with a better prototype. So innovation succeeds through informed iteration. And with that, ladies and gentlemen, we have come up to the end of this session of innovation methodologies. And if you want to look at those, I will share these slides. And maybe if you do have something else that we can talk about, or something that you have not understood, or anything you would like, you have liked to know, or an addition to what we have learned, it could be useful. But this is the time. This is time. You can just enable your microphone and then ask the question. You don't have to raise your hand. Uh, uh, well, uh, just ask the question or a comment, enable your microphone. You are free. You are free to do so. And if there are no questions, comments, additions, or anything else, um, let me take this opportunity to thank you for your participation. Remember to uh, actualize your idea. Believe in yourself. Let it not be a reason why your idea did not become an innovation. The other thing is a human being or humanity is a social animal. It's good to work with other people. Um, that is the human nature. And if you want to know how good that aspect of social works, just look at languages itself. Nobody can claim they discovered language. Language is a communal process, and language is as simple, is as complex as mathematics. Anything you do, uh, walk on a beaten path. Yeah? Visit peer journals, watch YouTube videos, DIYs, or any other process. Also remember, anybody can innovate. Anybody can innovate. It's not just for experts. Okay. So any question? Nahashon Kamemia, how are you? Patti, Milka, Vega, Naomi, Jane, Juliet. Thank you for participating. Until another time. May God bless you.
Thank you, Bwana Wambugu.
Okay.
It was enjoyable.
Pleasure.